This lecture is essentially on electron configurations. We're going to use the Bohr concepts, which have electrons traveling in circular orbits, and sometimes we call those orbits electron shells, as we're going to see clearly in this activity. So what we're going to do is, as Bohr has shown, he has shown that in his his atomic model, having a nucleus that's positive and having these planetary model of electron orbits that differ in their energy according to their proximity to the positive nucleus, we're going to show how electrons actually are arranged in each atom according to their energy levels. We know the electron shell or orbits that are closer to the nucleus have, of course, lower energy, and the orbits that are farther away have higher energy. And we know when we excite electrons, they gain energy of exact nature, and they can move to this position. Now they're unstable and they jump back. But now we're going to start putting the electrons for atoms, and you say atom, I say neutral, atom, neutral. So because we're dealing with atoms today, neutral, we know that the protons equal the electrons, and we're going to start organizing the electrons, start arranging where these electrons exist in their ground state. So the arrangement of the electrons isn't haphazard. It goes from low energy to high energy. So electrons will fill these orbits in a certain pattern from low energy to high. Now they call that the Aufbau principle, but you don't have to know that. But you do know that electrons will fill from lowest energy to highest energy. Now, what we understand is hydrogen, if you look on the periodic table, only has one proton and one electron. And if you don't know, we go to the periodic table and we move our periodic table to find the H, which is for hydrogen, and we see it has an atomic number of 1. And as an atom, it has one proton, and as an atom neutral, it must have one electron. So where do we put this electron? Well, we put this electron, okay, in the first shell, because I only have one electron. So if you notice, they did hydrogen for you. It has one proton in the middle, and they have this one electron written here, okay, as a black dot, but I'll put the red here, the blue now. This electron here, there's only one, so it goes in the first energy level. So we go to helium. Well, helium has 2 protons and 2 neutrons. We know that from the periodic table because helium is given a 4 above and a 2 below. 4 minus 2 gives us the 2 neutrons because a neutron and a proton have the same mass. We have 2 electrons and 2 protons. These electrons fill the second shell, or the extra electron. So this is how we do that. Now notice when we go to lithium, we have to add an extra shell. Well, how do I know that? Well, if we go to the periodic table, there's a couple of clues here. All right? The clue is this. If I look at my periodic table, okay, and I can see that this number, okay, number 1 is the first shell. So in the first shell, there's only 2 electrons, right? Hydrogen has 1, and helium has 1 more. Lithium has how many electrons? Well, it has 3 protons, but it has what? 3 electrons. Notice we're starting the second shell. So for lithium, we draw the inner circle. Obviously, we have 3 protons and 7, we round this number. Minus 3 is 4 neutrons, and surrounding that, we have 2 orbits. The first orbit has 2 electrons. The second orbit has only 1 electron. Okay, now beryllium has 4 electrons. You may say, well, how do I know I keep filling? Well, we're still in the second energy level, the second shell, the second orbit. So when we go back, let's do that. Okay, let's do beryllium. The element is called Be. Okay, and we know that it has 4 electrons because Be, beryllium, has atomic number 4. Okay, now so we know it has 4 protons, go in the middle, And to get neutrons, we go back to our periodic table. Okay, let's make it bigger because I can. All right, move this around, and we get beryllium, and it has 9 over 4. So 9 minus 4 is 5 neutrons. So we write 5 neutrons in the nucleus. Now our first circle has to include 2 electrons. And if you noticed already, 2 electrons fill the first energy level. How do I know? In row 1, that's the first circle, there's only 2 elements. So therefore, only 2 electrons fill. But because it has 4 protons and 4 electrons, because it's an atom neutral, we're in the second energy level. The second energy level, we have to add, what? The second, the third, and the fourth electron. And you can guess, we go on to the next one, boron, don't be one. It's atomic number 5. It has 5 electrons. Okay, if you consider, here's the first energy shell. Hey, there's 2 electrons in the first energy shell. We fill those first 2. Those are the lowest. Then in the second shell, we have 1, 2, 3 electrons. If you're getting the pattern here, make sure you put the right number of protons and neutrons inside. Okay, now we got carbon. Carbon's atomic number 1, 2, 3, 4, 5, 6. So it's got 6 protons in the middle. Find the neutrons. You have to put them in there. But it has 6 electrons. 2 fill the first energy shell. Well, if it has 6 electrons, the second energy shell, and again, I'm in the second row, second shell, n equals 2, right? Have you seen that before in my diagrams? N equals 1. All right, so in the second shell, I must have 4 electrons remaining, or 4 electrons in the second. Can you guess how nitrogen fills? How oxygen fills? How fluorine fills? And of course, how neon fills. Okay? Make sure you get the right protons and neutrons, but nitrogen's atomic number, what? 7. So it's got 7 protons. And my next question to you is, how many electrons do you think fill the second shell? Now, the third row, okay, should have, this is going to be n equals, this is the third row. How many shells do you think are here? Well, how many fill the first? Always 2. And then you're going to add a second ring. You're going to figure out how many fill that. But if we were in the third row, we're filling in the third ring or the third shell, or when n equals 3, right? All right, so you're going to try that on your own and keep going. Now, what I will say, there's another way to do this that might make some sense. Look at lithium, okay? Let's go back to lithium. All right, oops, going back to lithium. All right, I'm going to go back to lithium. I see it has a number, 2-1. You might have been noticing this 2-1 number. Okay, so let me try to circle it here. This 2-1 number is an electron configuration. The 2 means I have 2 electrons in the first energy level. The dash means that the next number is for the second energy level. So that means I have 2 electrons, that's the ring with 2 electrons in the first energy level, and then the next ring or orbit or shell, I've got what? Another electron for a total of what? 3 electrons would equal the protons. Okay, look at boron, beryllium. It's got 4 protons, but what? That's also 4 electrons because it's an atom, neutral. Look what we have here, 2 electrons, 2-2. So you got 2 electrons in the first energy level, and then you got 2 in the second. How does that look different? You would add an electron. So these numbers show us and actually tell us in our periodic table what and how the electrons are arranged. Notice in the third row, what shell are we working on? Yes, we're working on the third. That means the first energy level is filled with 2. The second is filled with how many? Whoa. And then we have 1 more. Okay? We're putting that 1 on the outer ring. And then we add another electron. Look at this one. Where do you think the electron's going? Yeah, it's going on the third ring and you're adding. So the periodic table gives you a lot of information. So when you go back to your problem here, oops, not that. Okay, the configuration tells you how many electrons and where they go. For instance, carbon is 2-4. What does that mean? 2 electrons are in the first energy ring, or in n equals 1, and 4 are on the second. You're getting my drift, hopefully. Now, I want to give you 2 more definitions and I'm done. Okay? I want to give you something called valence electrons and core electrons. Valence electrons, okay, that should be an A there. Valence, oh, I'm sorry, E, I'm bad Grodsky. Okay, so I have valence electrons. And valence electrons are the outermost electrons. So if I've got a configuration of 2-1, which really means what? 2 electrons are in the inner shell, and then I have 1 electron in the outermost. The valence electron is the 1. It's the outermost electron. Then we have something called the core electrons, and I should color code this, shouldn't I? Okay, so the kernel electrons, oops, it's not letting me write there. It's not like and like. So kernel is another word for core electrons. These are the inner electrons. And as you've already learned, these electrons are more stable. So here are my inner electrons. And 2-1 tells me that what? I have 2 inner or core or kernel electrons, and color coding this, and valence means I have 1 outermost. Which one do you think is easy to remove? The one that's closest and being controlled by the nucleus, or the one that's farther away? Yes, the ones that are easy to remove are the valence electrons. Okay, they are not as stable. Kernel electrons are very stable. Okay, they're going to stay that way unless you add them. Remember, valence electrons are a little what? Unstable. Does that sound like something we've learned already? The stable electrons are where? On the inner. These are called the ground state electrons. And of course, we learned that when they can become excited. Now, understand that the configurations that we're learning, for instance, this is 2-1. Who is 2-1? 2-1, my friends, is lithium, 3 electrons. We call this ground state configuration. These are the configurations where electrons what? Fill the lowest energy level first, then the higher energy level. That's why we fill the 2 first. Okay? So for oxygen, I'll just do one more. Oxygen is atomic number 8. You're going to figure out the protons and the neutrons. But if I've got 8 electrons, that means I have what? 2 core or kernel electrons, because 2 fills the first energy level. And then I have what? Well, 2 plus what is 8? 6 electrons are valence electrons. They're the outermost. If I draw 6 here. And if I'm look at O, I should see a 2-6 under my O, okay, in my reference table to see that. Let's go find O, and we find that. Boom, 2-6. 2 in the first ring, 6 in the second energy level, and we're always filling electrons right in the second energy level. Here we're filling in the third. Okay, so what I want you to do, party people, is continue on. I want you to tell me protons, neutrons, and electrons. I also want you to tell me the valence electrons for each one of these. Okay, and then I want you to do the best you can to answer these questions. Okay, now if you don't get these right, I don't care, but I want you to try the best. It's not imperative that you get these right now, but it's imperative you understand how to use and how to fill these electrons. Okay, take care.